In the name of Almighty Allah, the most gracious, the most merciful. Assalamu alaikum, my dear students. I am Tahir Irfan, A-level chemistry teacher from Roots International School, A-level campus, Sialkot. Today we are going to understand the chemical behavior of benzene. That is one of the fundamental concepts in chemistry. Here we have a copy of periodic table with us. Okay, first of all, the benzene ring. As you can see, I have drawn a molecular formula, displayed one, in which I have shown some carbon atoms making alternatively single and double covalent bonds, like here. And each carbon atom is connected to 5 hydrogen atoms through a covalent bond. So this particular structure is called benzene. Now this is the displayed formula for benzene. Sometimes we call it benzene ring. And if we are going to write it in skeleton formula form, we can write in this way. As you can see, a 6-corner shape hexagon with alternatively single and double covalent bonds. Okay, very important. In many books, you find the shape of benzene ring like that. There is no alternation of single or double covalent bond. Rather, there is a hexagon and a circle under that. So basically, the reason of putting circle around is that the position of double bond is not fixed. It's not fixed that the double bond lies between these two carbon. This particular double bond can shift towards these two carbon as well, or this particular double bond can shift toward this particle and this one towards these two carbon. So in fact, the double bond is not fixed here in benzene ring. This is different from other unsaturated hydrocarbons, where we find in most of the cases the position of double bond is fixed. So actually, the double bond is not fixed as it is shifting in nanosecond. So we can simply draw a round circle saying that the double bond alternatively single and double covalent bonds can be found anywhere. So this 3D diagram will make it more clear. As you can see, carbon atom is making 6 covalent bond with hydrogen, and they are also connected to make a 6-corner ring, hexagon. And you can see that each carbon atom has a 2p electron that is not making any bond with other. So these electrons are available for making double covalent bond. As we know that the double covalent bond is formed when there is a sigma bond and the available pi electron are overlapping sidewise to make a pi bond. So these electrons are available for making pi covalent bond. So there is equal chance that a pi bond can be formed in this way or alternatively towards this side as well. So that's why we put a round circle that these 6 carbon can make double bond towards either side. So basically, this shifting or delocalized double covalent bond gives extra strength and chemical stability to benzene ring. In comparison, when we see the double covalent bonds, they are chemically more active. For example, addition is possible in double covalent bond through mild chemical reaction, but that particular addition will not be possible in benzene ring because the overlapping or shifting single and double covalent bond, they give it more strength, and more chemical in reactivity. So this will further be covered inshallah in the coming videos, in which we understand the difference between simple unsaturated and the um, behavior of aromatic compounds. So organic hydrocarbon containing one or more benzene rings are called arenes. It is possible there is one benzene ring, it is possible there are 2, 3, 4 benzene rings, they are connected to each other. So those hydrocarbons, if there is none other atom, so we call them as arenes. In general, compound of benzenes are known as aryl compounds. So aryl compound is a more better word for that. Aryl compounds or aromatic compounds. Aromatic compound. Traditionally, uh, these chemical compounds of benzene or its derivative, they were called aromatic compounds. Aroma means sweet smell. So when benzene was discovered and the chemist analyzed it, they found that it was sweet smelling, just like you can see a cup of coffee, like the smell we find from a delicious cup of coffee. So those chemists used to name these sort of compound as aromatic because they mostly were producing sweet smell. So traditional name was aromatic compounds. Now we have a better name, that is aryl compound. Aryl compounds, they are either benzene or they are derived from benzene. It is also possible there are other atoms joining here. For example, it is written, an example is chlorobenzene. Chlorobenzene. Suppose if one chlorine atom replaces hydrogen atom. For example, this hydrogen atom is replaced by a chlorine atom. So that will be chlorobenzene. And in this skeleton formula, we will put a covalent bond and write Cl here. So that particular will be chlorobenzene, which is one of the halogenoarene. As we can see, halogen, the chlorine atom is halogen, and arene, the benzene ring. So the derivative of benzene ring containing one chlorine atom. Okay, here we can see overlap of p orbitals produces a ring of delocalized electron. Now please be very careful. These delocalized electrons are not those which we find in metals, which are responsible for electricity conduction or heat conduction. So please don't be confused. We only use the word delocalized electron above and below the plane of benzene carbon atom to understand the position of double bond here. These delocalized electron cannot move from one place to another. So it is not possible that electricity is going to be conducted. So we just use the word delocalized electron to understand the position, relative position of the single and double bond. Thank you very much.